Welcome to Essentials of the Earth Climate System. Today we're going to talk about Chapter 9, Climatic Types on Land. Well, it's a busy slide, so because we're going to talk about the major climatic types on land, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We are going to talk each type of the major climatic types on land in detail. So, and we're going to see those types in continental areas, especially in terms of their temperature and precipitation regions. The distribution of these types in the context of the Köppen classification of climates that I'm going to show you a slides about the Köppen classification global distribution. We're going to discuss the approaches to climatic classification. So for the main classification, we based on seasonal characteristics of temperature and moisture, but more specialized ones are based on thermal comfort or agriculture conditions. There are also classifications based on the causes of climatic patterns. We begin by considering some of the most spatially extensive types of climate. For example, we will start with deserts, monsoons, and high plateaus. In each case, regional differences are discussed. Then we going to turn to wet lowlands and move forward through the different latitude zones to the polar regions and ice sheets of Greenland and Antarctica. So, here is the picture of the Köppen climate classification. There are many approaches to classify climates. The earliest dates back to the Greeks, who recognized the change of temperature with latitude. They identified torrid, temperate, and frigid zones. The primarily variable that characterize a region are generally its temperature, rainfall, and in particular, their seasonal characteristics. Essentially, temperature values can be divided into about 5 classes and precipitation distinguished according to its seasonal distribution: year-round, summer, maximum, winter, maximum. This is the basis of W. Köppen's classification referred to earlier. And Cress and A. Alcoa provide budgets of Rn, Le, and H over the annual cycle for 10 of Köppen types. Another approach is to consider the moisture balance, precipitation minus evaporation, and its seasonal distribution as proposed by C.W. Thorne-White in the United States in 1948. Numerous authors have developed variants of these schemes. A. Miller, Kosky, and G. Threadweather, for example. Others such as Buchter and W. Tunging developed physiological classification of thermal comfort. and Papadakis developed an agriculturally based classification, genetic classification based on air mass, frequency, and airstream boundaries have been proposed by W. Wenderland and Bryson. A very thorough annotated bibliography on climate classification has been compiled by R.F. Truss. It must be recognized that all classifications are arbitrary and the boundaries between categories will sometimes be indistinct. However, where there is a topographic feature such as mountain range or coastline, the boundary will be sharp. So the first classification is desert. So we're going to define desert first. A desert is a barren area of land where little precipitation occurs and consequently living conditions are hostile for plant and animal life. The lack of vegetation exposes the unprotected surface of the ground to the processes of denudation. About 1/3 of the land surface of the world is arid or semi-arid. This includes much of the polar regions where little precipitation occurs and which are sometimes called polar deserts or cold deserts. Deserts can be classified by the amount of precipitation that falls, by the temperature that prevails, by the causes of desertification, or by their geographic location. So desert in Köppen system is BW. So it occupies approximately 25% of the global land area based on the Köppen classification. Hence, they are major elements of global climate. They are regions that are almost devoid of vegetation with very low rainfall, typically less than 250 millimeter per year, but their temperature conditions vary greatly from one to another. Their surfaces must be maybe sandy with giant dunes, stony gravel, or bare rock pavements, dry river channels, which are occasionally subject to fresh floods, traverse them. Deserts are formed in several ways. Major one developed in the subtropics, where persistent anticyclones as associated subsiding air create clear skies and low relative humidity. The hot deserts of North Africa in the 9 million kilometers Sahara and of Arabia in the northern hemisphere and Australia in the southern hemisphere are prime examples. The high pressure centers that are responsible are apparent. A second type occurs with interior basins that are remote from moisture sources and surrounded by mountain ranges. The mid-latitude Gobi, right here, Gobi, mid-latitude Gobi, around 44 north, bounded by the Altai Mountains and the Tibetan Plateau, Altai Mountains, and Taklamakan. So 41 north, bordered by the Kunlun The Pamar and the Tian Shan ranges in northeastern China are examples. A third type is coastal desert in the tropics and subtropics, where cool offshore currents add to the effects of subsiding in air in the subtropical high pressure belts for fog and low stratus frequently from in the cool, moist ocean and are drawn inland by sea. Vegetation is a crucial moisture source. Um, so moisture air and are drawn inland by sea breezes. The Namib Desert in southwest Africa. So it's right here, Namib. Um, Africa. So, and the Atacama Desert in North Chile are examples. So, coastal areas of Namibia have greater 100 days of fog annually. The associated fog dip in onto cactus vegetation is a crucial moisture source. The Arctic Atacama is the driest desert in the world because moisture is blocked by the Andes to the east and by the Chilean coast range to the west. Some locations appear never have received any precipitation. So, a fourth type of desert is called polar desert, distributed to low atmospheric humidity and infrequent weather systems that result in low precipitation in polar deserts. The ground is usually frozen and the permafrost permanently frozen ground may be hundreds of meters thick. Temperature conditions in deserts vary widely according to their latitude and continentality. The Sahara is very hot in summer, but relatively cold in winter, with occasional frost and snow on the 3,000 meters mountains. The Hagar and the Tibesti within it. The Gobi and Taklamakan deserts are extremely cold in winter, with occasional snow and hot in summer. Polar deserts have annual precipitation of less than 250 millimeter, falling as rain in summer and snow in autumn, with a mean temperature during the warmest month below 10 degrees Celsius. Winter temperature average -40 to -50 Celsius degree. Polar deserts are found in the Canadian Arctic archipelago, northern Greenland, and the Siberian Arctic islands, as well as in the dry valley of Antarctica west of Makochudo Sound. In the last area, mountains block potential moisture sources and downslope. Katabatic winds from the Antarctic plateau sublimits snow and ice. So annual precipitation thresholds for desert climates depend on the seasonality of the precipitation. Winter precipitation is subject to much less evaporation than that falling in the summer. Relative humidity also displays strong seasonality.